For problem number 37, it says that a sports car rally, a car starting from rest accelerates uniformly at a rate of 9 meters per second squared over a straight line distance of 1,000 meters or 100 meters. The time to beat in the event is 4.5 seconds. Does the driver beat this time? If not, what must the minimum acceleration be to do so? So this is the task. This is what the question is really asking is, if the car accelerates at 9 meters per second squared and it has to travel 100 meters, will it do it in less than 4.5 seconds? If it doesn't do it in less than 4.5 seconds, what acceleration would you have to go at to get to beat the 4.5 seconds? So the first thing that we would need to do is I would need to know, I know a couple of things, and so we're going to jot down what it is that we know, and then we're going to apply some formulas to kind of figure out exactly, what we need to know. So we start off with what we know, list that first, and then we're going to attempt to try to calculate what we don't know through the equations. So what did they tell us? Well, they told us a couple of things. They told us that at some point in time we need to consider the fact that the time to beat was 4.5 seconds. The other thing that they told us is that the distance, or delta x, is going to have to be, or the displacement is 100 meters. They told us that there was a possibility that the acceleration is going to be 9.0 meters per second squared. All right, and so what we can do then is try to figure out how much time, right? So this is our first time, but how much time would it take us to travel the 100 meters if we were to accelerate at 9.0 meters per second squared? How long would it take us to get travel 100 meters? So let's draw a picture. So here I am in this little race car, right? And this is 0 meters, and I've got to get 100 meters in, hopefully I could do it in 4.5 seconds. I have an acceleration of 9.0 meters per second squared. And so what I want to do is I got to figure out that equation, or I got to find an equation based on the information that they've given me. Well, there is one equation listed in the back of the book, and there's a couple of them, but there's one equation like the velocity is equal to the initial velocity plus the acceleration times time. The problem is I don't know the final velocity. There's another one that says that the average velocity is equal to the velocity plus the initial velocity divided by 2. Again, I would kind of toss that one out right off the bat because it doesn't have time. There's another equation that says x is equal to x naught plus 1/2 times the final velocity plus the initial velocity times time. Again, I don't know what the final velocity of this thing is, so I don't know how helpful that would be. Although it does have time. Remember, we're looking for things that have t for time because that's what we're solving. Okay, here's another equation. X is equal to x naught plus the initial velocity times time plus 1/2 times acceleration times t squared. Okay, well, I know the acceleration, I'm solving for time, and I know the displacement. It's the initial velocity that's kind of an issue for me on that one. But I think they said the car started from standing still, so the initial velocity should be 0 meters per second, right? So if my initial velocity is 0 meters per second, then this is the equation that I could use. This has all the information that I need, right? So how do I got to do some things to clean this up a little bit, of course, but so one thing that I could do is if I subtract x naught from both sides of the equation, then I have something that looks like this. Well, we recognize that x minus x naught is really delta x. And since my initial velocity is 0, that whole term is going to be equal to 0, so that kind of goes away. So I get delta x is equal to 1/2 times the acceleration times time squared. Well, let's plug some stuff in. So now I've got 100 meters is equal to 1/2 times the acceleration, which is 9.0 meters per 1 second. Probably should draw it like this. Times time squared. Oh, the acceleration is seconds squared. Alright, so let's zoom in a little bit, see what we're working with. So mathematically, this is 100 meters is equal to 1/2 of 9 is 4.5 meters per second squared. Now, if I want to get rid of this, I would divide by the fraction on both sides. And whatever I do on one side, I have to do on the other. And I don't have to write the 1 second squared, but I am going to write it down just for the fun of it to remind myself that that represents 1 second squared. So whenever I divide something by a fraction, I really multiply it by the reciprocal, don't I? So anyways, we know that this is equal to 1, so on my right hand side I've got t squared. On my left hand side though, I've got 100 meters over 1 times the reciprocal, which is seconds squared, all over 4.5 meters. Now because Mr. Adams wrote the units in there, I noticed that my meters cancel out, and so now what I have to do is I have to plug this into my calculator and determine what 100 divided by 4.5 is. So let me pull up my handy dandy calculator here. I'll probably have to take a second to turn on. Probably should have turned it on before I began this problem. It's alright. I should like hum Jeopardy music. Doom 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 doom. I could have done this problem in my head by now. Doom 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 doom. Boom boom. All right. So I've got 100 divided by 4.5, and that's 22.2. So now I've got 22.2 repeating. Seconds squared is equal to time squared. Well, I don't want time squared, I want time. So what I'm going to have to do is take the square root of this side and the square root of this side. Okay. So the square root of 22.2 repeating, if I hit second this, and then plug in second answer, close my parentheses, and I get 4.71 seconds. So that was a lot of work, but what I have shown was that if my car right here is traveling at 9 meters per second squared, it will take me actually 4.71 seconds to get from 0 to 100 meters. So yeah, this is not fast enough. So that's part A of the question. Now we have to do the part B. So part B wants to know is how fast would you need to go? In other words, what would you need to accelerate at? So let's think about that. If I accelerated at 9.0 meters per second squared and it wasn't fast enough, then I would need to accelerate at I'd have to have a higher acceleration in order to make that distance in the 4.5 seconds. But now what I want to do is I want to solve and see how much time it would take to do that in 4.5 seconds. So here's the easy way to do it. I know that delta x would be 100 meters, right? I know that the time would be 4.5 seconds, and I know that the initial velocity would be 0 meters per second. And then I guess really what I'm trying to figure out is what the acceleration would be, right? Does that make sense? So if I take this long equation that we chose before, which was x is equal to x naught plus v naught t plus 1/2 times the acceleration times time squared. And algebraically, again, I'm going to manipulate this so it'll help me do better. I'm going to minus the x naught from both sides. I get x minus x naught is equal to velocity, the initial velocity, times t plus 1/2 times the acceleration times t squared. We know that the initial velocity is 0, right, because the car's standing still when it starts. So this whole thing goes away to 0. We know that x minus x naught is delta x. So I'm left with this equation of 1/2 times the acceleration times time squared. Well, I know that this is equal to 100 meters times is equal to 1/2 times the acceleration. That's what we're solving for, times time squared, but we said that it needs to be done in 4.5 seconds squared. Okay, so I have a bunch of numbers, and let me plug this in. This is seconds. I have a bunch of numbers now. I basically need to solve. All right. So what I'm going to do is I'm going to get out my handy dandy calculator, and let's take 4.5 and square it, and see what we get. 20.25, and then that's going to be multiplied. 20.25 is going to be multiplied by 1/2. So I'm going to say times 0.5. And so this times this thing squared is equal to 10/125. So I've got 100 meters should be equal to 10.125 seconds squared, right? Because we're going to square the seconds times the quantity A. You guys with me so far? So to solve A, what I'm going to do is I'm going to divide this side by 10.125 seconds squared. Then I also have to divide this side by 0.125 seconds squared. These cancel, and I get my acceleration is 100 divided by 10.125. So my acceleration would need to be 9.8765, and we'll round that. And then notice that it's in meters per second squared. So what we've just calculated is that two things. One, 9 meters per second squared was not fast enough. If I needed to complete, in other words, let's draw the picture again. My car is starting here at 0 meters. Okay, and it needs to travel 100 meters. It needs to go from here to here in 4.5 seconds. Then what we've calculated is that it would need to accelerate. It would have to be greater than or equal to 9 point, and if I were to round that, 9.9 meters per second squared. Okay, and so from standing still, which is an initial velocity of 0 meters, if the car were to accelerate at a constant rate of 9.9 meters per second squared, it would travel 100 meters in less than 4.5 seconds. That's it.